This is Jacob's Algebra, Chapter 12, Lesson 5. This lesson is about multiplying square roots. Now, we've learned already that you can't take two square roots and add them together to get the sum of the number under the square root. Square root of 2 plus square root of 3 does not equal square root of 5. We can't add things that are under square roots. But square root of 2 times square root of 3 does equal square root of 6. So anytime you have two square roots that are being multiplied by each other, like square root 7 times square root 4, we can just multiply what's under the square roots and say that that is square root of 28. And in this case, we'd look at square root of 28 and say that's 4 times 7. So the square root of 4 is 2. This would be 2 root 7. Now, anytime that you're multiplying numbers with square roots, like say 3 square root 2 times 4 square root 3, what you're going to do is multiply the numbers outside the square root together and then multiply the numbers inside the square root together. So outside of the square roots, we have a 3 and we have a 4. 3 times 4 is 12. Inside the square root, we have a 2 and we have a 3. 2 times 3 is 6. So this would be 12 root 6. Remember to be very careful that when you are multiplying numbers with square roots, that the numbers outside get multiplied by the numbers outside, and the numbers inside get multiplied by the numbers inside. If you had 3 root 2 and we multiplied that by 7, 7 is not in a square root, so it cannot be multiplied by this 2 that's in a square root. Numbers outside a square root get multiplied by numbers outside a square root. So the 7 and the 3 are multiplied together to get 21, and then our square root 2 is just copied. If we had 3 square root 2 times square root 7, we wouldn't multiply anything by the 3. We would just copy our 3. There's nothing outside the square root here. Then we would write our square root, and our 2 and our 7 are both inside the square root. 2 times 7 is 14, so we would have 3 root 14. Remember, the numbers outside a square root get multiplied by the numbers outside a square root. The numbers inside a square root get multiplied by numbers inside of a square root. Okay, now at the beginning of this lesson on page, on page 582, there are several patterns which that are shown to you because these are patterns that you need to learn to recognize. If you have A times B plus C, you can multiply that out to get AB plus AC. Similarly, if you have AB plus AC, you can factor out that A to get A times the quantity B plus C. If you have A plus B times C plus D, you're going to multiply your A by the C to get AC. You're going to multiply the A by the D to get AD. You're going to multiply the B by the C to get BC. And then you're going to multiply the B by the D to get BD. BD. The other way you could do this, of course, is to, whoops, that didn't do it, is to draw a grid, put in your grid lines, and write your problem out this way. A plus B times C plus D, and we get AC, AD, BC, and BD, sorry, that's a D, which is the same thing that we have up here. Okay, the next pattern that we're shown is capital A. Let me redo that. Okay, is A plus B quantity squared. Anytime you are squaring the sum of two numbers, we're going to take our first term and square it. We're going to take our last term, which is the B, and square it. And in between these two, we're going to put the double of the product. So that's going to be 2 times A times B. So it's the double of the first term times the second term. If these two terms are added, then this is a plus. If the two terms are subtracted, then it's a minus. So if we have a minus b squared, then we would have a squared minus 2ab plus b squared. So be sure to look for this anytime you are squaring the sum of two terms. You will have three terms in your final answer. You will square your first term, you will square your last term, but there's also going to be a term in the middle, which is the double of the product of your first and last terms. If you're adding the two terms, that's going to be positive. If you're subtracting the two terms, then it's going to be negative. And the last thing to be sure that you recognize is if you have the sum of two terms multiplied by the difference of those same two terms, what you're going to have is the first term squared minus the second term squared. And of course, if you see the square of some number minus the square of another number, what you're going to have is the first number plus the second number multiplied by the first number minus the second number. So if you had something like 4x squared minus 9, 4x squared can be written as the quantity 2x squared. 9 can be written as 3 squared. That's a difference of two squares, which means I could factor this as 2x plus 3 times 2x minus 3. Okay, so now let's look at some of the problems in the chapter. So the first problem we're going to look at is number 4. Number 4 is just like number 9 that I assigned for homework. It says multiply and simplify. So first we're going to look at part B, which is square root 20 times square root 2. Everything is inside of a square root, so we can multiply everything together. So this is equal to the square root of 40 because 20 times 2 is 40. Now, anytime you have a square root, you always want to look at that and say, is there a square factor in that square root? We can write 40 as 4 times 10. 4 is a square factor. So if we pull the 4 out of here, the square root of 4 is 2, and then we're left with a 10 inside the square root. So our answer is going to be 2 square root 10. Now let's look at part C. Part C is the square root of 11 times the square root of 99. Well, everything is under a square root. That means that we can multiply everything together. So we have 11 times 99. And if you look at the 99, there is actually a square factor in there. We could write 99 as 9 times 11. And we know that we have this 11 up here at the beginning. Well, if we have an 11 times an 11 under the square root, that means that we can take those two 11s out and make them just an 11. 11 times 11 is 121. The square root of 121 is 11. And then we have this 9 under the square root. The square root of 9 is 3. So this is 11 times 3, which is 33. Another way that we could have looked at this is as the square root of 11 times 3 times the square root of 11, because 99 is 9 times 11. 9 is a square factor. We can pull that out. Take the square root is 3, and we have an 11 left behind. And then what we can do is multiply our 3. And then when we multiply a square root 11 times a square root 11, we get an 11. Anytime you multiply a square root by itself, you get the number you're taking the square root of. So square root x times square root x is x. Square root 3y times square root 3y is 3y. Square root 27 times square root 27 is going to be 27. Squaring something and then square rooting it, or square rooting it and then squaring it, those things undo each other. Okay, let's look at a couple more parts from number 4. If we look at number 4, part G, what we have is 10 square root 2 multiplied by 10 square root 18. So first I'm going to multiply the numbers outside the square root. 10 times 10 is 100. Now I'm going to multiply the numbers inside the square root. 2 times 18, that's 36. But 36 is a square number. So if I take the square root of 36, I get 6. So this is going to be 100 times 6 And 100 times 6 is 600. So next let's look at part H. Part H says square root 3 times square root 14 times square root 42. Okay, when you're looking at this, 3 times 14 actually is 42. So we can look at this as square root 42 times square root 42. Anytime you multiply a square root by itself, what you get is the number inside of the square root, so the answer is actually 42. Now I want to jump down to part L. Part L is square root 3 times square root 27 plus square root 3. What we're going to do is multiply the square root 3 by the square root 27 to get square root 81. And then when we multiply square root 3 times square root 3, we're multiplying a square root by itself, so that means that we get the number inside the square root. Now square root 81, we can actually find that because 81 is a square number. The square root of 81 is 9, and then we're going to add our 3. 9 plus 3 is 12. I want you to take careful note of number 4L because on the solutions that I attached to the homework email, I actually stopped at square root 81 plus square root 9 and for some reason did not finish out the problem. So the square root of 81 is 9, square root of 9 is 3, 9 plus 3 is 12. That's the way that problem finishes. So this was number 4. It's just like number 9 that I assigned for homework. Next, let's take a look at number 5. Number 5 says multiply and simplify. Assume that x is greater than 0. We're assuming that x is greater than 0 because in Algebra 1, we don't take square roots of negative numbers. You will learn how to do that in Algebra 2, but that's not covered in Algebra 1. So in Algebra 1, if you get the square root of a negative number, your answer is not possible or no solution. So let's look at part C, which says the square root of 8x times the square root of 18x. Okay, when we look at this, we're going to multiply our 8 times our 18. And 8 times 18 is 144. X times x is x squared. So 144, when we take the square root, we get 12. The square root of x squared is x. Remember, square root is a half power. So anytime you need to take the square root of a power, what you're going to do is cut that power in half. So if you had square root of x to the 24th, that's the same as x to the 24th to the 1/2, and that's going to be x to the 12th. Square root cuts your power in half. So whatever power you have, you're going to end up with only half of it. Okay, now we're going to look at part D. Part D says 5 square root x to the 5th multiplied by 7 square root x to the 7th. So we're going to multiply the numbers outside the square root first. 5 times 7 is 35. And then inside the square root, we have x to the 5th times x to the 7th. When we multiply numbers that have powers, we add the powers. So this is going to be x to the 12th. Remember that when you take the square root of powers, square root is a half power. So we're going to take half of 12. This is going to be 35x to the 6th. Okay, next we're going to look at part F. Part F is square root of x times 4 plus the square root of x. Okay, 4 times the square root of x. The 4 is outside a square root, so it stays outside the square root. The x is inside a square root, so it stays inside a square root. Square root x times 4 is 4 root x plus square root x times square root x is x. Anytime you multiply a square root by itself, you get the number you are taking the square root of. That is number 5. It is just like number 10 that I assigned for homework. The rest of these problems will be covered in the part 2 video.